All right, everyone. Assalamu alaikum. Let's begin. Can someone please quickly confirm if you can see my screen?
Yes, sir.
All right, good. Let's begin then. So we were doing quadratics. We are done with binomial earlier. We were done with a number of concepts on quadratics as well. Let me quickly remind you about what we have done until now. We've talked about how we can solve quadratic equations using factorization, using quadratic formula. We talked about what these values represent. We talked about shape of quadratic graphs and some things related to that. We talked about finding the turning point. We can do that using this formula, minus b over 2a. We can find the x coordinate of the turning point using this formula. Then we can find the corresponding y coordinate as well. In the last class, we talked about how to complete square of a quadratic function. Okay, so there were two methods that we discussed for this. One was using minus b over 2a and remembering this form. I'm sorry, where did that go? Yeah, so one was that we could remember this form and just input the values of a, h, and k in this by using the formula minus b over 2a first to find the h value and then putting that back in the function to get k and then just inputting those values here. That was one possibility. We also discussed the other method that most of you have done in O levels before, in which we take the coefficient of x squared common first of all, then inside the brackets, what we do is we divide the coefficient of x by 2, square that, add that, and also subtract that inside the brackets. Then we write that as a perfect square and then multiply the number outside inside as well. Okay, that's what we talked about. We talked about how to find the turning point given one of these forms. And we discussed another completed square form that sometimes they ask for in questions, in which you have a coefficient of x inside the square. That can also sometimes happen, that inside the square you have some coefficient of x like this. We discussed how we can convert to that form. So one possibility was that we just convert to the standard form first of all, like this, and then write the number outside as a square as well, and then multiply the bases together, and that gives you the result. That was one possibility, and then there was another method as well that I thought some of you might be able to do directly like this as well. So this is what we discussed in the last session. Today, we are, number one, going to do some practice questions on this, and hopefully if we have enough time, we're going to talk about the concept of discriminant as well. But first of all, we'll have enough time, inshallah, to discuss the concept of discriminant. Before that, you can let me know if you have any particular questions from the worksheet, if you tried any, or we could just start with that concept first. We could do it either way. So anyone who has attempted any questions from the worksheet and got stuck, let me know. We can see if we can discuss those questions first before discussing the next concept. So yeah, let me know. Any problems from the worksheet, first of all? No? Okay, so if there are no problems from the worksheet, I would just assume that you understand all of these concepts until now. And we will discuss the next concept then so that you have something to work on over the weekend. We will discuss the next concept, and then you'll be able to do a number of questions from the worksheet. So let's start from that, and then we can do a couple of examples after that. So let's start with the next concept then. And that is about using the discriminant. Using the discriminant. Let's see what this is about. Now, remember we talked about quadratic graphs, how they look like. There are two possible shapes. You could have an N shape or a U shape. That's what we said. Let me draw here some possible graphs that you can have if the graph is U-shaped. So let's think of a U-shaped curve. Let's think of a U-shaped curve. This is how it would look like, right? This is a U-shaped quadratic function. Now, there are actually multiple possibilities as far as its intersection points with the x-axis is concerned. So let's assume this is the x-axis. If you have a U-shaped curve, what are the possible cases that you can have there? One possible case is, I have to extend it a bit first. One possible case is that you get a graph like this such that it intersects the x-axis at 2 points like this. This is one possibility. Okay, this is one possibility, that you have 2 points of intersection with the x-axis like this. You have one point of intersection here, and you have another point of intersection here. This is one possible U-shaped graph that you can have. Another possibility could be that you have a graph like this, such that it just touches the x-axis like this. So it does not intersect it at 2 points, it just touches it like this. Okay, this is the second possibility for a U-shaped graph, okay? It could be like this. And then another possibility could be that the graph does not intersect the x-axis at all, and it's like this. This is also possible. All right. These are the three possible U-shaped graphs that you can have. Okay. They could either intersect the x-axis at 2 points, or just touch the x-axis at 1 point, or maybe just not intersect with the x-axis at all. All right. Now we want to understand, without drawing the graph, how can we figure out which one of these cases it is? So just by doing some quick calculation on a function, we want to figure out, is it the first case or the second case or the third case? That's what you want to figure out. Okay. Now let's try to understand this concept using 3 different equations. I'm going to write down 3 equations here, and I would want you to solve these equations quickly. Let me write down the first one here. The first one looks like this: x squared minus 7x plus 12 equals 0. Okay, this is one equation. Let's solve this. Then I'm going to write down another equation here. Let's say we got something like this: x squared minus 4x plus 4 equals 0. And then you could have another equation that looks like this: 3x squared plus 4x minus, or in fact plus 15 equal to 0. Yeah, so we have these 3 equations. We want to solve these 3 equations. And what I want you to do is, I want you to solve them using quadratic formula. Do not use factorization, even though I understand it would work on the first case and the second case, yes. But we don't want to use that. So there's something that we want to understand out of this process. And that is going to be best understood if we were to use quadratic formula for these 3 equations. Now, what about the first one? Let's solve the first equation. How would we solve the first equation? If we were to use the quadratic formula, it will look like this: x equals minus into minus 7 plus minus square root of minus 7 whole squared minus 4 into 1 into 12. Right? That's the numerator of the quadratic formula. Then in the denominator, we have 2 times 1. Let's simplify this. We have 7 plus minus square root of 7 squared is 49. 49 minus 48, that turns out to be 1. So we have 1 here divided by 2. Now what we do is we split this into two parts. We have 7 plus 1 over 2. And we have 7 minus 1 over 2. The first one gives us 4 and the second one gives us 3. So these are the two values of x that we get. X equals 4 and x equals 3. So this is the first type of graph. So this function, you can think of it like this. You can say this function is y equals x squared minus 7x plus 12. How do you find x-intercepts of this function? We put y equal to 0. If we put y equal to 0, we get this equation, right? What are the solutions that we're getting from this? 3 and 4. So this equation, the first one, intersects this function, the first one, it intersects the x-axis at 2 points like this. All right, 3 and 4. Let's try the second one. Let's try the second one and see what happens to that. X squared minus 4x plus 4. Let's apply the quadratic formula in this case as well. X equals minus into minus 4 plus minus square root of minus 4 whole squared minus 4 into 1 into 4 whole divided by 2 times 1. What do we get from this? 4 plus minus square root of 16 minus 16. That turns out to be 0 divided by 2. Now let's split it into two parts. Again, there's a reason why I'm doing this. We get 4 plus 0 over 2. And we have 4 minus 0 over 2. What does that give us? The first one gives us 2. The second one also gives us 2. So from the second equation, we are getting x equals 2 or x equals 2. We're getting the same solution again and again. That means there's only one point that actually exists on that graph, and that point is this point. This is the second type of graph. In this case, the graph only touches the x-axis at one point like this. Okay, what function is this? This function is y equals x squared minus 4x plus 4. In order to find the x-intercept of this graph, we put y equal to 0. That gives us this equation. And that has only one solution, or you can say two equal solutions. So the curve only touches the x-axis like this because it only has one solution. All right. What about the last one? Let's try and solve this one. How do we solve this last equation? 3x squared plus 4x plus 15 equals 0. Again, let's use the quadratic formula. X equals minus 4 plus minus square root of 4 squared minus 4 into 3 into 15 divided by 2 times 3. What do we get from this? We get minus 4 plus minus 16 minus 12 into 15, which is 180, right? 16 minus 180, that will be minus 164 inside the square root, divided by 6. What do we do to this now? Well, square root of negative number, that does not exist. At least for now, it does not for us. We will see later when we do paper 3. In complex numbers, it does. But for now, we know that this is not possible. We can't take square root of a negative number. So this is not possible. What does that mean? There are no solutions to this equation. So the last equation had this function, had this equation, y equals 3x squared plus 4x plus 15, if this was the function. And we were trying to find the x-intercepts of this function by putting y equal to 0. We don't get any answers from this. What does that mean? It does not have any x-intercepts at all. Okay, it does not have any x-intercepts. So that's how the graph would look like in that case. It lies totally above the x-axis, right? There's no point of intersection with the x-axis. Make sense? So we solved three equations. We solved the first one. From the first equation, we got two solutions, and those two solutions were both different from each other. Then from the second case, we got two solutions again, but both of those solutions are actually equal to each other. So another way of saying that same thing would be that we are getting only one solution, because in essence, it's just one, because the two numbers are actually equal to each other, right? And then in the last case, we're not getting any solution. All right. Now, by looking at this working, can we figure out what exactly is it that is giving us two solutions in the first case, and they're both two different solutions, equal solutions in the second case, and then no solutions in the third case? What's the most important thing in this whole working? Can anyone spot what exactly is giving us these different cases? What is different between these cases that's basically giving us sometimes two values, two different values, two equal values, and then in the third case, no values at all? The key, yeah?
B square minus 4ac in the
Before
quadratic equation.
yeah, so basically, if you look at this working, if you look at the number inside the square root, in the first case, it's a positive number, right? It's a positive number. It's 1 in this case. It could be any other positive number as well. If it is a positive number, its square root would exist, right? And then what we do is we add this number to 7, we subtract this number from 7 as well. By adding that number once and then subtracting it once, we get two different answers, right? Because one we will get by adding that number, and then another we would get by subtracting that number. So we get two different answers in this. In the second case, however, inside the square root, we had a 0. Now, if it doesn't matter if we add this 0 to 4 or subtract the 0 from 4, 0 added or subtracted does not make any difference. So the results that we're getting here are equal. So if the number inside is positive, we get two different answers. If the number inside is 0, if it's equal to 0, we get two answers still, but they're both equal to each other, right? So on the graph, it's going to be just 1 point rather than having 2 points. Okay. And then what about the last case? In the last case, the number inside the square root is negative. When the number inside the square root is negative, we can't even solve that, and we get no solutions from that. From the last case, we don't get any solutions. So this number that we have inside the square root, this is actually very important, because that is deciding whether we're going to have two different answers or equal answers, or maybe no answers, no x-intercepts. So what's this number inside the square root? Where is this number coming from? If you look at the quadratic formula, this is what the quadratic formula looks like. X equals minus b plus minus square root of b squared minus 4ac whole divided by 2 times a. Inside the square root, what you have is b squared minus 4ac. So what we understand from that discussion is this thing is something really important, because that's what is deciding whether we are going to have two solutions or two different solutions or two equal solutions or no solutions. Okay, so this thing is really important. Now, since this thing is really important, what we do is we actually have given this a name that we can refer it by, and that is discriminant. So this thing, b square minus 4ac, is called discriminant. B square minus 4ac. Why? Because it discriminates, it differentiates between the three cases that we're getting here: two different solutions, two equal solutions, or no solutions. This is what tells us which one of these three cases it's going to be. Okay, so from this discussion, what we understand is there's something about this discriminant that we need to know. Let's write that down now. So in the first case, what was that? Discriminant was positive. So we can say One possibility is that b square minus 4ac is positive. That means it's greater than 0. Then another possibility is that b square minus 4ac is equal to 0. Sometimes you would have this. And then the third possibility is that b square minus 4ac is less than 0. These are three major cases that we are going to be looking at. There's going to be one more, but that's just going to be a combination of two of these. Let's stick to these three now, for now. What happens if b square minus 4ac is greater than 0? That means if it's positive. What you have is, when you solve that equation, when you solve that quadratic equation, remember we're talking about quadratic equation only, b square minus 4ac is only relevant for quadratic equations, not for any other kinds of equations. So don't use this anywhere else. It's only for quadratic equations. Okay, what about the first case, when b square minus 4ac is greater than 0? When it's greater than 0, what you have is two real and distinct. Distinct means different. Two real and different solutions. You can call these solutions, or sometimes we also call them roots. So you should be familiar with both of these terminologies, roots or solutions. If b square minus 4ac is greater than 0, you get two different answers. You get two distinct answers. Like we got here in the first case, we had 3 and 4. We had two different answers there. Okay. In the second case, when b square minus 4ac is equal to 0, we say we have two real. Now, what are real numbers? Real numbers are basically all numbers that you know about until this point. So let me actually explain after writing this. So the second case is two real and equal solutions. Or both of those solutions are equal. You can also say that's just one real root, right? That's another valid way of referring to this as well. You can just say there's only one root because they're both equal. Although mathematically speaking, we call them two roots, but sometimes you can, roughly speaking, you can also just refer to it as one real root because those two real roots were actually equal to each other. Now, why are we specifying real? Because as we'll find out later, although there are no real roots of this equation, there are some other kinds of roots that we do not know about until for now, and we do not even need to know for paper 1. We would need to know that for paper 3 later, but that's not for now. Real numbers are basically all numbers that you know about until this point. So basically all categorizations that you know of, for instance, integers, decimals, fractions, positive numbers, negative numbers, rational numbers, irrational numbers, whole numbers, natural numbers, all of those different types of numbers that you've heard about, those are all subcategories of real numbers. Okay, so they're all real numbers. Okay, so any number that you know of until this point, they are real numbers, as long as you have not done complex numbers yet, because the other kind of number is called complex number, but that's not needed for paper 1. So to qualify that, we're not talking about complex, we're talking about real. We just write it like this, that we're talking about real roots. Okay, so b square minus 4ac, if it's greater than 0, that means we have two real and different roots. If it's equal to 0, we have two real and equal roots. Okay. Then in the last case, when b square minus 4ac is less than 0, we don't get any solution. So in this case, we say there are no real roots. There are no solutions in this case. All right. That's what it means in each of these three different cases. Make sense? The first one has two real and different roots. The second one has two real and equal roots. The last one has no real roots. Okay. That's their meaning algebraically. There's also a graphical meaning that you also need to be familiar with. So if you look at this graph, for instance, we have two graphs here. One is the curve. In each case, we have a curve. So in the first case, for instance, we have this curve and we have this line. In the second case as well, we have this curve and we have this line. In the third case as well, we have this curve and we have this line. So we're talking about a curve and a line. In this case, we were talking about x-intercept. So the line is x-axis, okay? But as we will find out later, the same idea can be extended to other lines as well, okay? So you would have cases like this where you have a curve and that is intersecting with a line like this at 2 points, right? In this case as well, you would say b square minus 4ac is greater than 0 because there are 2 points of intersection like this. Then you could have another case in which you have a curve which is a tangent to you have a curve and then there's a line that's a tangent to the curve like this, such that it's only touching the curve at only 1 point. In this case, you have only one root like this. Okay, it's not x-axis, but it's another line that's just touching the curve at 1 point. And then the last possibility could be that you have a curve and then you have some other line that's just not intersecting the curve. So it's not necessarily x-axis always, like in this case, although it works for x-axis as well. It could be some other line as well. So in this case as well, on the right side, in the first case, you have two distinct solutions. So b square minus 4ac is greater than 0. In the middle case, you have two equal solutions. You can say one solution, one real root. B square minus 4ac in the second case would be 0. And then in the last case, the line and the curve, they're not intersecting at all. You'll say there are no solutions. So when you're explaining this graphically, there are some terminologies that they will be using in problems that you need to be familiar with. B square minus 4ac greater than 0. Algebraically, it means you get two real and distinct roots. Graphically, what that would mean would be that the line, whatever that line is, and the curve, they intersect at 2 points. The line and the curve, they intersect at 2 points. Or you can say the line intersects the curve at 2 points, or the curve intersects the line at the 2 points, okay? That's what it means graphically. So sometimes in the question statement, they would be writing something like this, that this line and this curve, they intersect each other at 2 points. Now that should remind you of this, that, okay, that means b square minus 4ac needs to be greater than 0. All right. In the second case, where you have two equal and real roots, or you can say one real root, the line is meeting the curve in one specific way such that the line is making a tangent with the curve, right? In this case as well, and if you look at the right side here as well, the line is making a tangent with the curve. So the terminology that they use in this case is, they would say the line is a tangent to the curve. So whenever you see that that line is a tangent to the curve, that should remind you of this. Okay, this is one statement that they might be that they might be using here, or sometimes they also write like this: the line touches the curve at only 1 point. That, in other words, means that the line is a tangent to the curve. Okay, so when you have statements like these written in the question, the line is a tangent to the curve, or the line touches the curve at only 1 point, That should remind you of this, that okay, that means b square minus 4ac should be equal to 0. And then in the last case, when there are no real roots, graphically, what it's going to mean is that the line and the curve, they do not intersect. They neither intersect or meet. So they could use intersect here or meet here or any similar word like this. So the line and the curve, they do not intersect or meet each other. That's the last case that we have. Okay. So whichever statement they use here, understand which case it refers to. So if there are two equivalent, if there are two equal roots, you have the second case. If the line is a tangent to the curve, you have the second case. If the line does not intersect the curve, it's the third case where it's less than 0. If the line and the curve intersect at 2 points, it's the first case, and so on. Okay. So you need to be able to recall which case a certain statement refers to, because that you will need to use that then in that problem. Now, I hope that makes sense. In some problems, what they do is they write like this. They would say that there are real roots, or graphically, they might say something like this: the line meets the curve, or the line and the curve, they meet each other. What do you understand from this? Either they say there are real roots, or that the line and the curve, they meet each other. Can we say anything about the discriminant in this case, b square minus 4ac? What should that be? Any idea? What do you understand from these statements?
It should be greater than or equal to 0.
Greater than or equal to 0? Why?
Because because it says that there are real roots, but doesn't say if there are two or just one, or one real root, and that the line does meet, but doesn't say if it meets twice or just once.
Yeah, so that's very good. So if they make this statement that there are real roots, now how many real roots? Are there two real roots? Are those two real roots equal? Are they not equal? We don't know that. So it could be the first case, it could be greater than 0, or it could be equal to 0, it could be any of them. Similarly, if they make this statement that the line meets the curve, the line meets the curve. Now, at how many points? Does it meet at 1 point? Does it meet at 2 points? We don't know that. If it meets at 2 points, that means it should be greater than 0. If it meets at 1 point, it should be equal to 0. So what this case is doing is it's combining the first two. Okay, it's a combination of the first two cases. These two cases, greater than or equal to. So sometimes this is what you need to do, that you need to put b square minus 4ac greater than or equal to 0 like this. Okay. So these are the different cases that we have for discriminant that you need to remember now. We will be using these concepts now to attempt some questions. Okay, so let me know first if you have any problems. Otherwise, we can move on to some practice questions. Any questions on this, anyone? Any problems? So we have done a number of things in this topic until this point. So you need to now be able to recall all of them now that we start doing questions, because we will be referring to different concepts and each question. Every part will have something different. So you need to now be able to recall all of this. So what have we done? How to solve quadratic equations. We talked about shapes of quadratic graphs. In this case, remember, we also talked about increasing graph, decreasing graph. When gradient is positive, graph is increasing. When gradient is negative, graph is decreasing. We talked about this. We talked about finding the turning point, completing square process, and then we discussed this discriminant. So you need to be able to use all of these concepts now. So now let's begin with some practice questions from the worksheet. So the worksheet is already uploaded. I hope you have started doing some questions from the worksheet already. In the next class on Monday, we're going to start by discussing some practice questions. So please make sure that you've done enough practice by then. Okay. I'm getting this feeling that you're not really doing the practice questions regularly. That is important. Please make sure that you're doing that, because otherwise this whole time is going to get wasted. You will just forget everything after a week or so. So make sure that you're making notes, taking your own notes of these classes. Along with that, you should be practicing questions, a lot of them, many of them, at least the assigned questions, but then you should try more as well from recent papers. There's very little time left now, so you can't waste it anymore. Okay, let's start with this one. Question number 1 from the worksheet. It has a number of concepts tested. It's a good question from that perspective. So let's think about this. The equation of a curve is y equals x squared minus 3x plus 4. So we have this quadratic function given. We need to show that the whole of the curve lies above the x-axis. How do we show this? I'll give you a minute to think about this. How do we show that the whole of the curve lies above the x-axis? Any idea about this?
We show that b squared minus 4ac is less than 0.
You could show that b squared minus 4ac is less than 0. Okay. Is that going to be enough? B squared minus 4ac is less than 0. Achha, by the way, let me actually go back here. I gave you one example for a U-shaped curve here. And in the first case, b squared minus 4ac would be greater than 0. In the second case, it would be equal to 0. And in the third case, it would be less than 0. But it could also be N-shaped curve, okay? What happens if it was an N-shaped curve? Let me actually draw that here at the bottom. If it was an N-shaped curve, I'm sorry. If it was an N-shaped curve, in the first case, you would have something like this, intersecting at 2 points. In the second case, you would have something like this, right? Just touching the x-axis. And then in the last case, you would have something like this, that it does not intersect the x-axis at all. So in U-shaped curve, these would be the 3 cases, right? In the first case, you have 2. In the second case, you have 1 point where the line and the curve meet each other, where the line is a tangent to the curve. And in the last case, you don't have any solutions. Right? The line and the curve, they do not intersect. So for N-shaped curve, this is what it would look like. So if b squared minus 4ac is less than 0, yes, one of the cases could be this, that the whole curve lies above the x-axis. But couldn't it also be this, that the whole curve lies below the x-axis? We need to prove that the whole curve lies above the x-axis. If we can prove that b squared minus 4ac is less than 0, we could have 2 cases. It could be this, but it could be this as well. So how do we prove that it's above? the x-axis. We would need to do something in addition to this as well. Or at least just write something in addition to b square minus 4ac.
The coefficient of x is positive, so we show that as well to show it's a U-shaped curve.
Yeah, so you write that the coefficient of x square is positive. Since it is positive, it is supposed to be a U-shaped curve, right? So you explicitly tell that it's not this case. It cannot be an N-shaped curve. It has to be a U-shaped curve. So both of these things together, that it's a U-shaped curve and b square minus 4ac is less than 0, that means the curve lies above the x-axis. Okay? Now, let me actually do this so the others understand as well. So it says, show that the whole of the curve lies above the x-axis. Now, what can the curve look like for it to lie above the x-axis? The only possibility is that it looks like this, right? It's a quadratic function. If it was to lie above the x-axis, this is what it should look like. It has to be a U-shaped curve and it has to be looking like this. Okay. N-shaped curve cannot lie above the x-axis. Does that make sense? N-shaped curve cannot lie above the x-axis as a whole. Some part of it can lie above the x-axis, yes. If it's like this part lies above the x-axis, but whole of it can't lie above the x-axis like this, because if you were to extend it, at some point it is going to come down. Okay, so the only possibility for the curve to lie above the x-axis is that it's a U-shaped curve and it looks like this. Now, how do we prove that? In order to prove that, one possibility is that we say, okay, this is the function y equals x squared minus 3x plus 4. Let's find b square minus 4ac from this. What's b square minus 4ac? b square minus 4ac, that is equal to b squared, which is minus 3 whole squared, minus 4 into a, which is 1 into 4, which is c. That gives us 9 minus 16, and that is minus 7. Now, since this is a negative number, we say the curve does not intersect the x-axis. This is what this is telling us. B square minus 4ac being less than 0, all it tells us is the curve does not intersect the x-axis. Okay, so it's telling us it's either this case, yes, but it could also be this case. So now you need to also specify that the coefficient of x squared is positive. These two things together mean the whole curve lies above the x-axis, because if the coefficient of x squared is positive, that means it's a U-shaped curve. And if it's a U-shaped curve and does not intersect the x-axis, this is what we get. So the whole curve lies above the x-axis. No part of it is below the x-axis. Make sense? So you would need to write down both of these things. The curve does not intersect the x-axis, and it's a U-shaped curve. Both of these things together mean the whole curve lies above x-axis. Any questions on this? Any problems, anyone? Others apart from Hazim, do you get this? Aisha, Arham, Hira, Maheen, Rajal.
Yes, sir.
Can you think of another method? This is one possibility. Okay, we show that discriminant is negative and It's a U-shaped curve, so the whole curve lies above the x-axis. Is there another way of thinking about this? Could we prove it another way? Any other ideas? Any other possible solutions to this? No. What if we find the turning point of this function? What if we find the turning point? This is the turning point, right? Can we use the turning point somehow to prove that the curve lies above the x-axis? Is that possible? What could we do if we do that? The coordinates, how would they tell us that
It would
the
show
curve
that it's
lies above?
above zero, so it would show that it's above zero. The y-axis are above zero.
Yeah, so if the coordinates are positive, so both coordinates or just the y coordinate, only the y coordinate matters. X coordinate could be anything because x coordinate is telling you whether the curve is to the right side or the left side. That's irrelevant. The only thing that matters is x axis has y coordinate equal to 0, right? If the y coordinate of the turning point is greater than 0, that means that the curve lies above the x axis. Okay, so we could find the turning point, and we know it's a minimum point because it's a U-shaped curve. Again, if the y coordinate of the turning point is positive, that means the curve lies above the x-axis. Let's try that as well. So that could be another possibility. So the function is y equals x squared minus 3x plus 4. The quickest way of finding the turning point that you know until this point is x equals minus b over 2a. Just input values in this. It gives you minus into minus 3 divided by 2 into 1, which is 1.5, or you can say 3 over 2. What about the corresponding y coordinate? Put this back in the function. 3 over 2 whole squared minus 3 into 3 over 2 plus 4. What do we get from this? What's this value? Okay, so this gives us 7 over 4. This is 7 over 4. You can write this in decimals if you want. This is 1.5 and this is 1.75. Now, coefficient of x squared again is positive. So we say the minimum point, so this is important, not just the turning point. We say it's a minimum point. The minimum point is 1.5 and 1.75. That means if the curve looks like this, the coordinates of the turning point are 1.5 and 1.75. Now, the x coordinate does not matter. That's irrelevant. The y coordinate matters because we are looking for the height of the graph, right? So the minimum value of the y coordinate is 1.75. So minimum value of the curve, minimum value of y is 1.75. This is greater than 0. That means since the minimum point is 1.75, you can't have a value that's below 1.75. So the whole curve therefore lies above x-axis because of that reason. Is that okay? This is another way of doing this. All right. So we find the minimum point. If the minimum point is if the y coordinate of the minimum point is positive, we say the whole curve lies above the x-axis. Okay, how that makes sense? That was the first part. Let's look at the second part. The second part says find the set of values of x for which this is a decreasing function of x. What about this? What's a decreasing function? We've talked about this before. Now we're running out of time actually, so I'll be slightly quicker so we can end this. Part 2. Okay, so it says find the set of values of x for which x squared minus 3x plus 4 is a decreasing function of x. Remember we talked about this earlier for quadratic functions. The graph is decreasing on one side of the turning point and increasing on the other side of the turning point. So if we look at this graph, U-shaped graph, we have one side here on the left side and another side on the right side. Can you tell me which side is decreasing? Which side is decreasing?
So
The side to
the
the
one
left.
on the left.
The one on the left, right? Because here the gradient is negative. So the left side is decreasing. What they've asked us for is find the set of values of x for which this is a decreasing function. Now, if we had used the second method in the first part, we would already have the turning point. Otherwise, we would have to find the turning point in this case. But now, since we've already calculated that, the turning point is 1.5 and 1.75. So on the x-axis, the turning point is at 1.5. Right? The turning point is at 1.5. Where is the function decreasing? If we were to the left of 1.5. So what would we say here? We would say it's a decreasing function if x is less than 1.5. For this, for these values of x, it's a decreasing function, right? To the left of 1.5, that's x less than 1.5. Is that all right? Yes. Okay. Let's move on to the next part. This was just a 1 mark question. We just have to write this like this, okay? All right, part 3. Now, part 3 says, the equation of a line is y plus 2x equals k, where k is a constant. In the case where k equals 6, find the coordinates. Find the coordinates of the points of intersection of the line and the curve. Okay, now this is something that we would actually discuss again in coordinate geometry as well, but you've done this in O levels. So let's just do this. Y plus 2x equals k, that's a line. And then we have a curve, which is y equals x squared minus 3x plus 4. It says k equals 8. 6, sorry. So in the case where k equals 6, the line is going to be y plus 2x equals 6, right? Find the coordinates of the points of intersection of the line and the curve. Points of intersection, that's what we are looking for. Now, how do we find points of intersection? We have done this in O levels for straight lines at least, right? So if you have a line like this and another line like this, how do you find this point of intersection? You used to solve them simultaneously, right? Solving simultaneously means you make one variable. So if you were to use substitution, for instance, you could make one variable the subject from one equation, put that in the other equation. That's exactly what you can do here as well. So you have a quadratic function. This is what the quadratic function looks like. Then the curve is y plus 2x equals 6. That will be a negative sloping curve like this, negative sloping line like this. These are the points of intersection that we're looking for. Okay. Now, how do we find these points of intersection? at the points of intersection, what happens is that the line and the curve are equal to each other, right? So this point and this point, it lies on both functions. So at these points, the line and the curve, they are basically equal to each other. So all we have to do is put the curve and the line equal to each other. Make the same variable the subject in both of them. You can make y the subject or x the subject. Generally, making y the subject is easier, and then just equate them. That's what we are looking for. Okay. Point of intersection. How do we find them? We just equate the two functions like this. So from the first equation, we can have y equals 6 minus 2x. The second equation is y equals x squared minus 3x plus 4. Now what we can do is we can just equate them like this. 6 minus 2x equals x squared minus 3x plus 4. And now we can solve this equation. And that will give us the x coordinates points. And then we can find the corresponding y coordinates as well. How do we do that? So this is the equation that we have. We take everything to one side. Let's take everything to right side, for instance. We would get x squared minus 3x plus 2x, that's minus x, plus 4 minus 6, that's minus 2. So this is the equation that we have, x squared minus x minus 2 equals 0. Can we factorize this? 2 and 1 minus 2. We could use minus 2 and plus 1, right? So it becomes x squared minus 2x plus x minus 2 equals 0. We can factorize it like this. That gives us x into x minus 2 plus 1 into x minus 2 equals 0. We get two factors, x plus 1 into x minus 2, x equals minus 1 or x equals 2. These are the two values of x that we're getting. These are the x coordinates of these points of intersection. What about the corresponding y coordinates? We can put these values of x in any one of these two functions. We can put them in any of them. But generally, your calculation is going to be simpler if you put those values in the linear equation, right? Why bother with this more complicated equation when you can do this calculation much quicker using this linear equation? So just put those values of x in the first equation. Y equals 6x minus 2. 6 minus 2x, sorry. Let's put those values here. Y equals 6 minus 2x. We could once input x equals minus 1. That gives us y equals 6 minus 2 into minus 1. Y equals 8. And in the second case, we have y equals 6 minus 2 into 2. That gives us y equal to 2. So one point that we're getting is minus 1, 8. And the other point is 2 and 2. These are the points of intersection that we were looking for. Okay, so in this case, the point on the left side, if it looked like this, the point on the left side would have coordinates minus 1 and 8, and the one on the right side, it would have coordinates 2 and 2. All right, that's what we get. Now, you don't have to draw this graph, of course. That's just for understanding what it means. You just have to do this calculation. So what did we do? We put the value of k, equated the two functions, and then solved it to find the 2 points. We found the two values of x first, and then put them back in the function to get the corresponding values of y. And we got those points. Okay, now that's the last thing. That's the last part before we end, because that is now going to be important to be able to attempt some more questions from the worksheet, part 4, because that uses the concept of discriminant now. Now, the last part is find the value of k for which the line is a tangent to the curve. Now, doesn't that remind you of something? The line is a tangent to the curve. We did that here. The line is a tangent to the curve. That was, here. The line is a tangent to the curve. What does that mean? B square minus 4AC is equal to 0. Okay, B square minus 4AC is equal to 0. So find the value of k for which the line is a tangent to the curve. Now remember, in the third part, we were given a value of k that was 6. That's not relevant anymore. And it said that clearly there. It said in the case where k equals 6. That means this case is not relevant for the other parts of this question. In fact, in the last part, you actually have to find the value of k. So it's not 6 anymore. So do not assume it to be 6 now. Okay. So what's the equation of the line then? Equation of the line is y plus 2x equals k. All right. So let me write that down here again. Equation of the line is y plus 2x equals k. And equation of the curve is y equals x squared minus 3x plus 4. This is the line and the curve. Now, since the line is a tangent to the curve, what we have to do is we have to somehow put b squared minus 4ac. That's what we want to do eventually. B squared minus 4ac needs to be put equal to 0. That's what we want to do. But how do we find b squared minus 4ac? You're not going to find b squared minus 4ac from this equation alone. B squared minus 4ac is found from an equation of this form. Ax squared plus bx plus c equal to 0. You need to have an equation in this form. Okay? Where you have 0 on one side, and on the other side, you have a quadratic function like this with only one variable, x in this case. Sometimes you could have y as well, but it can't be two variables. You can have y and x both in the equation. You only can have one variable and then 0 on the other side. From this, you have to find b squared minus 4ac. Okay. Now, how is this going to work then? What does b squared minus 4ac tell us? B squared minus 4ac basically tells us something about the points of intersection of these two graphs. That whether they're going to intersect at 2 points, or they're going to just at 1 point, or they're not going to touch at all. So we're talking about the points of intersection. We need something to do with points of intersection. Now, how do we find point of intersection of two graphs? We just talked about that in the third part, in the previous part. Whenever we have to find points of intersection, we equate the two functions. We make the same variable the subject, and then equate the two functions. In this case, if we make y the subject in the first equation, that gives us y equals k minus 2x. So now we have y the subject in both of them. So you first have to equate both of them. That's the first step. This will come later. B squared minus 4ac equal to 0. This will come, but not right now. First, you have to equate these two equations. So now you equate them. That gives you k minus 2x equals x squared minus 3x plus 4. So now you've eliminated y. It's only in terms of x now. You take everything to one side now, because you want this form. Ax squared plus bx plus c equal to 0. You take everything to one side and have only 0 on the other side. So since we have x squared here, we could maybe take everything to the right side, let's say. That gives us x squared minus 3x plus 2x. Let me just add another step. Minus 3x plus 2x plus 4 minus k, right? What does that become? X squared minus x plus 4 minus k equal to 0. That's the equation that you have. Now it's this form that you wanted. Now you compare it with that. Ax squared plus bx plus c equal to 0. That means a equals 1. B equals minus 1. What about c? Whichever term does not have an x in it, that's a constant. Both of these terms do not have x. So c is basically 4 minus k. All right. So whichever terms do not have x in them, they are constants. The coefficient of x squared is a, that's 1. Coefficient of x is b, which is minus 1. And then the constant term is 4 minus k. Now we use this. B squared minus 4ac should be equal to 0. What's the value of b? B is minus 1 whole squared minus 4 into 1 into 4 minus k equals 0. And that is going to give us the value for k. Let's simplify this. We have 1 minus 4 into 4, which is minus 16. Minus 4 into minus k, that's plus 4k. That gives us 4k equal to 15. and k equals 15 over 4. Or we could write it as 3.75. Since it's an exact answer, we could also write it in decimals like this. That's the value of k that we get from this. All right. Make sense? Any problem with this? Any questions, anyone? So now you should be able to do a number of questions from the worksheet, not all of them yet, because we don't know how to solve quadratic inequalities yet, but you should be able to solve the questions in the first row of the assigned questions. So if you look at Google Classroom, you have assigned questions there. Look at the first row of questions. You should be able to do all of that. Okay, so make sure that you do that over the weekend. And then we could discuss if you have any problems on Monday. And then on Monday, we will also be discussing how to solve quadratic inequalities, inshallah. Okay, any questions on this? Any problems, anyone? No, are you all tired? Okay. I think that's it then. If you don't have any questions, we are going to end here. I'll see you again on Monday. Allah Hafiz. Which chapter are we going to do after this? Achha, I will actually need to change the order a bit because there are actually some people who are taking both paper 1 and paper 3. I did not consider that earlier. So we would need to do some paper 1 topics that we need to use for paper 3 early. So for example, trigonometry, differentiation, integration, we would need to bring them forward a little. So I will need to think about this again, think about the order after talking to those couple of people as well who are taking both P1 and P3. And then I would be able to tell you the exact order. But just to give you an idea, these are the topics that we have. We are done with quadratics and binomial. We are going to postpone APGP for now. We're not going to do that because that's not required for paper 3. We are going to, we could potentially postpone coordinate geometry for a while as well. Which concepts are we going to need for differentiation? That's the gradient, and yeah, you already know that equation of line. Okay, we might have to do coordinate geometry. Yeah. So coordinate geometry, circular measure, geometry, differentiation, integration, and then most likely APGP and functions after that. That's most likely going to be the order. Yeah. So the next topic is going to be coordinate geometry, I think. Yeah. Next topic is coordinate geometry. After quadratics, we are doing coordinate geometry. Okay. That will be next week, at some point, I think, maybe Thursday. Before that, we should be able to complete quadratics. It depends on you. You need to make sure that you do enough practice. And let me know if you have any problems. All right, I think we need to end now. I'll see you again on Monday. Allah Hafiz.